All right, so just read these off real quick for you to make sure you got these right. Number 18 was log base 3 of 243 equals 5. You're writing it from exponential to logarithmic. Number 19, log base 51 of 1 equals 0. Number 20, log base 16 of 64 equals 1.5. 21, log base 7 of 343 equals x. The next four, you're going the other way. They give it to you as a log, you're supposed to write it as an exponential. So 64 to the 1.5 power equals 512. So 23, 2 to the negative 3 power equals 0.125. 24, 4 to the 70th power equals x. And 25, x to the third power equals 12. Any questions on those first 8? Just writing from one function to the other equation. Being able to go both ways. Again, you guys are pretty good at that stuff. All right, 26 was the kind that you had to do the mental math, all right? So it was log base 10 of 1,000. I told you to write equals x on those. And then write it in logarithmic form. I mean in exponential. So 10 is the base, x is the exponent, equals 1,000. And then try to write it with the same base. And you can. For anything with a 1 and zeros after it, it's 10 to however many zeros you have. So that's 10 to the third. So since the bases are equal, you can say x equals 3 then for that. That's what you're looking for. You're looking for the exponent. That's what logs are. The next one was log base 5 of 0.2. Right, equals x. So that's 5 to what power? Equals 0.2, which is 2/10, which 2/10 reduces to 1/5. So I can write 1/5 with the exponent, or I'm sorry, base of 5. 5 to what power is 1/5? -1, right? Okay, you know there's a 1 here. So if you want to move that out of the bottom up to the top, the exponent becomes negative. So my answer is x equals -1 on this one. Okay, so that's doing it mentally. Today we're going to learn how to do it using your calculator. Okay, the next one, number 28, is log base 0.5 equals 0.125. Not equals, but of 0.125 equals x. All right, so you're going 0.5 to what power equals 0.125. Okay? And I like to do fractions, so that's 1/2 to what power? And 0.125 as a fraction. That's 125 over 100. I'm sorry, 1,000. That reduces to 1/8. Okay? Well, 8 is 2 to the third. So what happens to that 3 when I move it up top? Well, I guess it's just 1/2 to the third. Never mind. Let me fix that. I could write it like this. So it's just going to be x is 3. Okay. And then the last one, 29 log base 1.1 of 1.21. Again, right, equals x. So that's 1.1 to what power is 1.21. All right, that's 1 and 1/10. All right, 10 times 1 is 10 plus 1, that's 11/10. And 1.21 is 1 and 21 100ths. 100 times 1 is 100 plus 21 is 121 over 100. So I can say 11/10 to what power equals 121 over 100. Okay. 11 squared is 121 and 10 squared is 100, right? So you could say x is 2 there. So that's how I would do it in my head. Again, we're going to learn some properties of logarithms today and translate between any base. And that's the one we're going to use our calculator for to do all these now. Okay? So let's see how you do. Remember, logarithms are exponents. Excuse me. So you can derive the properties of logarithms from the properties of exponents. All right, so if you have b to the m power times b to the nth power, what's the rule you're supposed to do? You have the same base, what are you supposed to do with the exponent? Add them, right? So the same thing works for logarithms. Okay? Basically, you're going to be giving it to it this way. If you have two logs with the same base and you're adding them, whatever those numbers are, you could turn it into a single log with the same base and multiply those two numbers. Okay? So what you're going to be asked to do is turn this into a single log by multiplying the two numbers and then simplifying it like we have them. Okay? Again. All right, so I have two logs. It's always going to have the same base. The base here is 6. So the rule is I can do what with the 4 and 9? No, multiply them. Okay, what's 4 times 9? 36. So now it's that problem. So then you just write equals x, and then you're thinking 6 to what power is 36? You guys all know the answer is what? 2. Okay, so you have two separate logs. It's addition. It's got to have the same base for this to work, but they will all have the same base when you do these. John, put the phone away and take that. Put it up on the corner of your desk. On the corner of your desk. Thank you. All right. So we're going to turn it into a single log and then do what we've been doing. So, what am I supposed to do with the 625 and the 25? Multiply them. That's a big number, so use your calculator. All right. All right, so 625 times 25 is 15,625. Okay, and then we're going to try to figure out what exponent gives us that. Okay, so we can just do this. 5 times 5 times 5. That's 3 times, right? Now, since I did it that many times, if I hit enter, it'll do it again. 4, 5, 6. So x equals 6. 5 times 5, times another 5, that's 3, times 5 is 4, times 5 is 5, times 5, again, 6 times, I multiplied by 5.
Okay.
Well, you can check then if you counted right. Make sure. And again, the last thing I show you though, you'll be able to look, just punch this in your calculator a certain way and you'll get 6. Okay? All right, again, what am I going to do with the 27 and the 1/9? Multiply, right? 27 times 1 divided by 9. You actually know it's 3. All right? So this is log base 1/3 of 3. Okay? So we're thinking 1/3 to what power is 3? Is there a way I can make 3 to the first look like 1/3? Reciprocate it, meaning what with the exponent? Negative, right? So okay, so what's the answer? -1, right? X -1. Again, today you'll know how to put that in your calculator and it'll give you the -1. That's the last rule I'll show you. So whenever we see 2 logs with addition, and how do I change it to a single log? What do I do with these 2 numbers? Multiply, right? Multiply those. And then again, the last property that I show you, you'll just use your calculator to figure it out. Okay? So, when you have division, what are you supposed to do with the exponents? Rules of exponents. Subtract. So, if you have 2 logarithms and you're subtracting, what do you do with the 2 numbers to change it to a single log? You know, we just had addition and we had 2 numbers. What do we do with them to make it a single log? We multiply. If it's subtraction, we're going to divide to make it a single log. Okay? Again, you have to have the same base. That's what this is saying. And you will. Okay? So what you're going to do, you're going to see this, and then you're going to divide 16 by 2 and say log base 5 of 8. And try to figure that out. Okay? So since it's subtraction, what do I do with the 100 and the 4? Divide. What's 100 divided by 4? 25, right? All right, so we're thinking equals X. So 5 to what power is 25? 2. Right, so the answer is 2. Okay? Again, once you get it to look like this, I'll show you how to put it in your calculator here in a few minutes. What do I do with the 49 and the 7? Divide, right? So this is log base 7 of 7. Right? 49 divided by that 7 is 7. Remember, we think of it like this. So 7 to what power is 7? First power, right? So X would be 1 for that problem. Or the answer is 1 for that problem. All right, so we got the subtraction now. We're going to do what with the 2 numbers? Divide, right, Trent? Okay. With addition, what are you going to do with the 2 numbers? Multiply. Okay. When you have log, well, this is log base what? If there's no number, what is it? 10, right? It's called a common log. Okay. If you have log base something of a number to a power, you can take that power, that P, out front of the log and multiply it. Okay? So if you have a log of some number to a power or exponent, that exponent can come out front and multiplied by the log. So that 6 here, what am I going to do with it? Put it out front of that log. Okay, and then we're going to do this problem first. Once we get the answer, what are we going to do with the 6 then? Multiply. Okay, so we're thinking log base 2 of 32 equals x, which is 2 to what power is 32? Right, so 2 times 2 is what? 4 times 2 times 2 times 2. 32. So 2 to the what? 5th, right? Okay. So that's where that 5 came from. And then 6 times 5 is 30. The answer is 30. Okay. Again, I'm going to show you here in a couple minutes how to put that in your calculator and get the 5. Just remember, you got to multiply by that 6 that was there in the beginning. All right. So, what do I do that for? Thanks, you guys. Come on, wake up. What's the base right now? 10, right? So this part, I'm going to do first. So I write equals x, I guess. So 10 to what power is 10? 1, right? So this is 4 times 1, which is 4. Okay? Here is 2 times log base 5 by 25. Right? So this part, we write equals x, right? All right? So 5 to what power is 25? Right? 5 squared, right? So this is 2 times 2, so what's the answer? 4. So both of those were 4. Okay? So when you see the exponent, you're just going to put it out front and multiply. So I do that 5, put it out front, right? So I think that. So 2 to what power is 1/2? -1, you're getting the idea, right? 1/2 is 2 to the -1 power. So what's my answer? -5. 5 times that -1. Okay? Making sense? Great. Making sense? All right. So here's a couple things that we just saw, actually. If the base of the log and the base of whatever that exponent is are the same, they just cancel each other out. So if we go back to this one, this was a base 10, right? We just don't write it when it's a base 10. Those are the same, right? The base of the log and the base of this exponent 4 were the same. They can cancel, and the answer is whatever that exponent is. Okay, so we could have, if we would have known that rule, we could have just said 4 right away. You know, if I rewrite this as log base 5 of 5 squared, actually 5 to the, 25 is 5 squared times 2, so 5 to the 4, those cancel, the answer's 4. So those are the same. Sometimes you get this weird looking thing. Those have a base, and in the exponent is the log of the same base. So those cancel. Whatever that number is the answer. So here they got 10 to the log base 10 of 2, the answer is 2. Here they got log base 10 of 10 to the 7th, the answer is 7. So those are like on site, you can see what the answer is just by looking at it. If your eyes are open, right, John?
Yeah.
So what's the answer here, Ian? Log base 3 of 3 to the 11th. If the base of the log and the base of the number, the exponent are the same, they cancel. Those the same?
Yeah.
So what's the answer?
11.
Yeah, just 11. Okay, those cancel. Oops. Okay. What about C here? Got 5, log base 5 of 10. What's the answer? 10. That easy, okay? I didn't want that. Just wanted to pull this over. I guess there we go. Those cancel. Now, these are not the same. All right, 3 to what power is 81? What's 3 times 3? No. What's 3 times 3? Times 3? Times 3. There it is. So 4. All right, so we can write this as log base 3 of 3 to the 4th. Those go away. So the answer is what? 4. Okay? What's this one? Wyndham. Good. There's no number there. What's the base? 10. So the 10 for the base of the log and the 10 here, we don't write it, but those cancel. Okay, that's log base 2 there. It just doesn't look right. So it's 2 to the log base 2 of 8x. So what's the answer? 8x. You guys get any idea on those? All right, here's the one you want to remember. This is the one you're going to want to use whenever you have to solve a log. Okay? We're just going to use common log, the log on our calculator, the one that says log, right next to the 7. Okay, we're going to use the base 10 log every time we do these. They changed this. This is called change of base formula or property. Right? Says that up there. They changed it to base 2, but I would just change it to base 10. Log of 8 divided by log of 4. That's all you put in your calculator. All right? When you hit log, there's a parenthesis, I think, that comes up. So close up the parenthesis. The base part goes in the bottom or the basement. Okay? That's the only part you'll mess up. You'll put the wrong number in the top and the bottom. So, this is log of what over log of what? Right, log of 8 over log of 32. You can put that in your calculator. and I'll give you the answer. I think it's 3/5. 0.6, that's 3/5. Okay, now I can show you why. Okay, 8 equals 2 to the third, and we just found out 32 was 2 to the fifth, right? So I could change them both to base 2, and then it's just 3 divided by 5, which is 0.6. Okay, but you don't have to worry about it. This was showing you. You just put in your calculator. Okay, so all those ones we did before, mentally, we don't have to do mentally anymore, right? Log of the top one divided by log of the base. Big numbers up top, the base in the basement. So what am I going to punch in my calculator? Log of 27 over log of 9. Should be 1.5. Get that? 1.5? Okay? So it's that quick and easy now. Log of what? 16 over log of 8. Should be 1.3 repeating. Did that happen? Those of you that are following along. Again, you can use a normal calculator to do this. You don't need a graphic one. It's got logs on it. Okay? That's it. Now, I don't think you can, if for some reason we didn't get that downloaded, so get a book, take a picture of it. That page didn't download when we did pages for this book from my Canvas page. So I'll put it right here. Take a picture of it with your phone. So you got it.